Hello, everybody, and welcome back to Build Amazing Things Securely Season 2. It's flying by, isn't it, team? We're already on 3 episodes into a season. Who knew? Now, today, I am really happy to be joined by a new friend who works at an amazing company called Fl0, but you know the rules. I'm not going to read a bio. That bores me to tears. So instead, Ryan, it's lovely to have you here. Welcome.
Thank you very much, Laura. Thank you.
And Ryan, who are you as a human?
Well, as a human, yes, I guess I'll start with the professional side and can get more into the human side. I'm the head of engineering at the company called Fl0 that you mentioned there. Have been there for about the last 9 months, and been involved in software in various sort of aspects since the very sort of early 2000s. Aside from that, as a human, I've got sort of two young boys, a wife and a dog, and some cats. And yeah, we sort of live in Sydney in Australia.
Fabulous. Now, you guys at home can't see it because I get to see people, and then I keep it from you just as like a weird tease. But he has a beautiful backdrop. It's all forests and things. We're all secretly jealous. Not so secretly in my case. Thank you so much for joining us, Ryan. It's awesome to meet someone not just who's doing something cool now, but who has, a few years behind them, much like me, where we've all been on adventures in our career. Now, Ryan, you have a whole bunch of things that we're going to talk about today. I know that you're a massive fan of the Rust language, and I think digging into that will be really, really useful. But I'd love to start with what you're building at Fl0. Not because of the product, we're not here to sell products one or the other, but we do look at the interesting things being built and how that affects security. So what is Fl0? What are you doing there?
So Dale and I saw the opportunity for really how can we empower an 11x engineering teams. That is, engineers are generally good at what they do. People have ideas, want to build products and ship them. And I've seen throughout my career a repeated pattern of, you see the same thing. Someone within a team becomes the infrastructure expert on, how do I deploy to production? How do I run it in prod? Organizations mature and they try and centralize that responsibility into whole teams that manage the infrastructure. And I've seen this pattern repeated at many, many places. And we really see Fl0 as the sort of next step here in really sort of democratizing the sort of the journey to infrastructure. And that is, how can we enable engineering teams to focus on the features that they want to build? How can we give them, the tools and the power so that they can continue to build them, that they are not wasting this opportunity cost on, writing thousands and thousands of lines of YAML to reconfigure their infrastructure and deploy their service over and over again. So what we're doing at Fl0 is really a really sort of streamlined process for engineers, teams, founders, technical or not, to get up and running and deploying services and products to our platform there without having to worry about the infrastructure side of things. So we take, their GitHub repo, we containerize it, we deploy it, we scale it, we manage it. And I think from our perspective, our focus has always been, back-end applications and APIs and deploying and scaling them. And we recently entered a partnership with Neon, the database vendor. So we offer sort of the backend services, Neon databases, things like that. So, and we do have a reasonably sort of well, obviously, I think a compelling roadmap of extra sort of things we want to build there. But really, it's about how do we enable people to build what they want to build? Like some people do, yes, but not a lot of people enjoy reconfiguring AWS or Azure or GCP sort of over and over again. So how can we sort of take that pain away and allow people to focus on shipping value for their product?
See, as a security nerd, this kind of idea, well, it fascinates me and horrifies me all at the same time. So bear with me. I'm not going to be mean, I promise. So I love the idea of not having to spend time on things that I'm not the person to do, right? I want to build an app that does X, Y, and Z. I'm not really fussed about doing all of the underlying things. Like there's a reason I use things like Twilio. There's a reason why I would use something like Stripe, because I don't want to write those things myself. It's just not worth my time. But then the security nerd in me kind of kicks in and goes, yes, Laura, but this sounds like a magic box. How do you know the magic box is doing all of the right things and going to keep the code secure? And then also, security nerd brain, I'm like, well, now there's lots of people on this server with me. So it's really, really interesting to understand how separated you are and how security works. So as somebody who's on the other side of this, who, builds it for a living, how does security work when you are, the ultimate end of multi-tenanted infrastructure?
I think security is our sort of, I guess, top priority and tenet in everything we build, because obviously if we have those breaches, and we'd like to strive and say we're never going to have these breaches, but I don't think that's
None of us
inherently rooted in
that.
reality. Yes, yeah, exactly. And so it's about the preparation we put in place, and that is that whole security through layers and making sure that we're the holes in the cheese aren't going to line up type thing. If you take that sort of metaphor from aviation, but also how we react to these things when they inevitably do happen. For us, we take it all the way down. Obviously, we run customer containers, we scale them, and we sort of deploy them across multiple clusters in various locations, and making sure that we keep that isolation as tight as possible between our tenants, our customers sort of running there, down to the fact that even between customer environments, the same customer, the same project running a dev and prod environment, not even having access there. And we do that through a network isolation layer, so making sure that we have zero sort of network connectivity between those two environments, between that customer and the connections we allow are only they're all allow listed. They're not just ad hoc. So we know everything that's been made. The customer knows everything that's been made in and out. On top of that, obviously there's the sort of preventative measures we put in place, but also the more proactive sort of monitoring and alerting and identifying where these connections are coming from, where they're going to, and how we sort of maintain that, and obviously monitoring to make sure that we've built a large amount of infrastructure and making sure that this stays secure and it runs, and then obviously monitoring and making sure that those assumptions are continuing to hold true and it is doing what we think it is doing.
Yeah, I'm going to be honest. Even just thinking about how much work it would be to do that yourself, I feel tired. It's a great thing that you can do these things yourself. You could spin up your own, AWS environment and build this type of thing from scratch. But my goodness, you are talking about not just a lot of time, but quite a lot of skills to understand the many layers and many components that are interacting there for that level of isolation. So I can totally see why there's a benefit to companies using something like yourselves or any of your competitors for, taking care of that aspect for you. How long would you say, if you were going to build it by hand, how long would it take you to build an equivalent containerized environment if you were going to just pull something off the shelf?
I'll get to. I just want to touch on something you mentioned before of people. Yes, they can absolutely go out and build it. We've gone out and built it, and many other companies have as well. And this is why I absolutely love my job, and this is the reason why I've always been an infrastructure nerd down in the guts of the machine, down in the engine room there, and how do we build it? And so being in a position where like that is my job, I absolutely love. And so in terms of building it, there's a number of different issues here. There's the terms of, you could build it very specific to your situation. You can, spin up either bare metal machines, run your own sort of containers there. If you don't have to worry about sort of other sort of services, other sort of bad actors potentially running on the platform, it's very easy to get up and running. But a lot of this comes through the sort of defense in depth that comes into play. And that is like, you want these layers, you probably want those isolation layers if you're the only tenant on the machine as well, in the sense that if something is compromised on the machine, you still have another layer of protection there, and you try to build up these sort of layers, this, as I said, defense in depth there. When it comes to how long it would take to build it, it's very much how long's a piece of string. I think I don't think software engineers are generally well known for their ability to accurately estimate engineering.
Hush. We're all perfectly good at this. We all got given those cards with numbers on them, and we've been great at estimating ever since. No, but I totally get your point on that. It's complex, right? And we don't have many infrastructure nerds come on, and I love that we've got one today, because I think we we spend so much time at the software layer that we start seeing everything as software. And it's really easy to feel that way. You've got Terraform and all sorts that you can play with. And, it's a similar environment. There is a lot to think about. And a previous guest of ours, he made a good point about picking the one thing that you can't change once you've made that decision and making sure you get that bit right. And I feel like there's some infrastructure decisions that you make early on that if you went down a pathway and did your own thing, it's going to be really hard for you to change later. So you're an infrastructure nerd. You decide you're going to build a product company. Yeah, but there's life choices there. We're not going to judge you. So how many people are in the company now?
So at the moment, we've got 11 people.
Amazing.
The vast majority of those are in Sydney, though we do have one in Canada and one in Israel.
Oh, very cool.
Yeah.
Well, the reason I ask, is we see all of our role model companies out there, those big names and brands everyone talks about, with hundreds or thousands of people, and securing things and keeping track of things when you're 11 people, as somebody who runs an equally small company, that's tricky. So how do you manage security over a product company when you're 11? Is it something that somebody owns or is it a shared thing? Walk us through it.
There's sort of two answers here. I think there's the whole security is everyone's responsibility, but I also subscribe to the shared responsibility is no responsibility type viewpoint there. And so making sure that we have the right sort of processes and tools and structure in place to make sure that, we can ensure that we sort of both are shipping the right features, the secure features, and that we can react when time is needed in incidents and emergencies to get to a right mitigation in a considerable amount of time. Now, this is a very I think this is a very large company perspective in the sense that yes, we'll put process around it, we'll put structure, we'll assign people to it and things like that. So there's, like any small company, small startups, there is the balance there of how do we move quickly? How do we actually ship value to our customers? Our infrastructure and, get them moving quickly, but doing it in a sort of secure and structured, sort of way there. And I think for us, this is, and I'm happy to say this is a bit of there is a lot of learning going on in terms of, how do we find that right balance between moving quickly and getting features out the door, as well as without imposing too much process and structure on our team there.
Yeah, and we see this a lot, right? Like the idea of minimum viable security and minimum viable process, if you will. And it's not that it lacks importance. It's just that you've got to make some really pragmatic decisions as to where to focus your time. Otherwise, you're going to get nothing else done. Now, I think we're going to do a really dirty segue and I'm going to make it look like it was supposed to happen. But I think it all links down as well to the technologies you're choosing to build from. Now, I mentioned at the very start, Ryan, that you are a Rust person. Is it safe to assume that there is a Rust component in Fl0, or have you gone completely, off your base and you're doing something else?
No, that is perfectly safe to assume. Or there's a very large Rust component within Fl0, the platform itself. And I've, for lack of a better term, completely drunk the Kool-Aid here. But it's a very I think it's very fit for purpose in terms of what we're doing. We, from a business perspective, it means that, every bit of compute we use is compute we can't sort of sell to our customers. So there's that side of things there. So the efficiency of the binaries that we actually build are there. The ability to move quickly and, defer a lot of issues to the compiler. Compilers are very good at doing this analysis task, doing repetitive tasks over and over again, and things that we don't have to have, our sort of, meat bags of software engineers do in their minds to work out, is this concurrency going to be safe? Is this potential for a use after free or an index out of bounds or anything like that? Deferring that to the compiler and the ability to move quickly. And I think all of these have been really, I guess, resonated with me. And to be perfectly fair, I've been a large proponent of Rust for a reasonably long time. And I think it was, I did bring this into Fl0 when I joined as well. And I think, the team have in all fairness, have really embraced a lot of this, and it has allowed us to move quite quickly over the last few months there, as we've it's been about 6 months since we introduced things there and started migrating it. And I think again, probably tangential to the security side of things here, but from I guess a logistical and hiring sort of and staffing perspective there, actually finding engineers in the Rust space is not that it's hard, but it's more that the engineers we do find, there's a very high signal to noise ratio there. So people are very motivated and keen to come and work on a Rust code base as well.
All right, awesome. Well, I think the Rust community is not one that I have really spent much time with, so this is quite exciting to me. So, indulge me here a little while I kind of dig into the Rust world a bit. What makes this language so exciting? Why? You mentioned that it's good at the compiler level and things, but if I was going to be starting out with Rust today, what is the moment that you found with it that you're like, oh heck, this is the solution to all of the problems I didn't know I had?
I wish it was the solution to all of my problems. Unfortunately, it is like any language. It's not perfect, and I think we're looking at incremental improvements here. It's I want to make sure we don't, and this is I guess the way I approach it. We don't set the bar as like it has to be the be all and end all. It's very much it has to be better than what we've previously had, and the things that Rust introduces in terms of this notion of a borrow checker. So when either data goes out of scope or it is no longer sort of valid in memory, the compiler will actually flag these, and you'll fight it. There's a common meme of learning the borrow checker and fighting the borrow checker when people start learning Rust. But making sure that we do have that sort of safe access to memory when writing and changing and hitting things, making sure that we can. I think before this podcast, I did a bit of research, and we look back in July, there were 33 CVEs for use after free. So just in July, there are 33 of them, sort of vulnerabilities ranging in, various. I think the highest I saw was a 9.8 score on the score there. And these are the exact things that this language is there to prevent. Like we've had C around from 70s, and it's got a long coloured history. We have C++ as well there, but a lot of these issues still sort of exist, and that's evident today, and that we see these vulnerabilities continuing. Even today, there are a couple of new CVEs that have come out here. So I think there's a large opportunity there that we can sort of wholesale cut out these whole classes of vulnerabilities in the software that we build.
I'm going to say something a little contentious, so sorry, audience, but I feel like we've actually done ourselves a bit of a disservice, you see, because we're mentioning use after free vulnerabilities right now. Now, those of you who have, started in the web space or in the last 15 years, you might have come across the OWASP top 10. Great, wonderful. Top 10 list of common web vulnerabilities. Nowhere on that list is a use after free vulnerability. Those classes of vulnerabilities, the ones that are associated with things like C and C++ and more traditional backend languages and server languages, we don't talk about them much anymore. Buffer overflows, to many of us, quite foundational or fundamental old school bugs, they are still very much present in the world. But we spend a lot more time talking about things like SQL injection and cross-site scripting, the more web-centric vulnerabilities. I think this is a really good reminder that not everything we're building is web, and not all of the software that we have has those categories of vulnerabilities.
Absolutely, and I think this is only going to become more prevalent over the last. Well, I was going to say the last 25 years, but I think that's a very sort of. That is my personal scope. But over the last, as computers have evolved, they've become more and more ingrained into our daily lives, like from our phones to the actual sort of hardware we run to the cellular radios that run their own OS inside of the phones that we have, to our cars, all of those things there. And there's a number of competing forces here in that vendors want to make these as efficient as possible, so they start, moving towards, especially in the embedded space, languages that don't have runtime. So that's your C, that is Rust in some cases, a bunch of, other languages there. But it also opens up these sort of other vulnerabilities. And so, when we get to the point of, maybe your car can be broken into because of some vulnerability in the Bluetooth stack or something like that, then it becomes, these are things that, they go beyond just some sort of trivial hack into having, actual sort of material impact on sort of how we live our lives.
I genuinely can't wait to have the conversation with my car insurer that explains that there was a theft of my vehicle due to a software vulnerability. I feel like that's going to be the most painful insurance claim that I ever do in my life. It's a really fascinating space. If you were to look forward to the future and technology that's being built right now or that's coming, what's the technology that you're most excited about, Ryan?
I'll be honest, I don't have a lot of knowledge in this area, and I think that's probably why it excites me, because I don't know the all of the underlying details.
I think that's a great reason to be excited about something. Yeah.
I think there's been this issue that has been around. Well, it's been around since compilers have been around, in the sense of trusting trust. So Ken Thompson wrote a paper in the early '80s about trusting trust. That is, how do you trust that the compiler you're using to compile source code is actually outputting source code that does outputting a binary that does what your source code said it would do. And so he came up with a proof of concept where he compromised a compiler that would know what it's compiling, would know if it's compiling itself. And so if it built another copy of itself, even from perfectly clean source code, it would include this vulnerability in the compiler. And you get this sort of, it just transmits along every binary you build, every compiler you build. And that is a really sort of interesting space in terms of language design, because you need to bootstrap a language somehow. And, nowadays, not everyone has the resources of some megacorps to go all the way back to some, very first trusted version of GCC so that they can build a new version of GCC, so they can build the Linux kernel to bootstrap their whole environment. Not everyone has that. We sort of start trusting it. But I think the area of interest here is really that sort of, there's this whole notion around the sort of chain of provenance and how do we actually trust what is coming to us. And, so many of us will just, fork what's on GitHub or pull down some Git dependency or something like that and run it in our code without actually understanding that, it could be compromised. And we've seen this, not to harp on Node, but I think the Node community's seen this, but many other communities have seen this as well, of pulling down dependencies that, you update them and they suddenly become malicious. So how do we sort of manage that chain of trust there and that sort of provenance of where the software comes from? And I know I'd say maybe, prior art here, I think there's been a number of false starts around, I used to be a big sort of crypto nerd in the sense, and crypto in the sense of cryptography, not crypto coins. So
you're not a crypto bro in the sense.
No, definitely.
No, okay,
definitely not in that sense. But in the sense of cryptography, and how do we establish that shared trust when there is no shared mechanism, and you read about sort of Diffie-Hellman and the key exchange protocol there, and then the early implementations of RSA, and I think. There's been certain parts of, I think particularly the open source community that have pushed a lot of, this in terms of how we encrypt emails and things like that. But even today, a lot of, there is, it is better. It is absolutely better than it was, but we're still not at the point of, it's, I guess if I PGP sign an email, it's, people are more likely than not going to say, what on earth is that is
yeah, I was going to say, you just out yourself as a security consultant at some point, to be honest. They're the only people I know who do it. I love you folks, but you're the only people. And I think the fact that you mentioned that paper from the 80s is a really, we have to keep in mind, like, we talk a lot about, software security and security in the supply chain of software. And, since Biden's executive order in the last couple of years about, having S-bombs and things, the whole world is trying to sell us an S-bomb maker. But this isn't new. The paper you're quoting is I was about to say 20, but I'm not 20, so it can't be 20. It's 80, so it's 30 plus years old. And we're still talking about these challenges now. And I think these are fundamental challenges. I don't think they're going to be fixed. late in the game by security folks adding on new tooling. I think they really have to start at the roots of our languages and our frameworks and how we build those ecosystems into a trusted state. You mentioned... carry on.
No. Sorry. I didn't mean to interrupt you, but I couldn't agree more. This is, and much like I guess any security posture, it's not something you can just sort of paint on top of what you've got. It's got to be a whole approach, and defensive depth is very hard to do if you're just doing a surface skim on top of whatever you've built. And it does get me down a bit because things are becoming more complex. People are bootstrapping compilers from machine code are going to be few and far between these days. I would hazard a guess. And then not only that is that the hardware is becoming more and more complex. Like the firmware, the microcode that goes into our processors is just like, it is this big sort of opaque box to us that we just don't know how it works. And that is the name of progress. That is a good thing. 30 years ago, have video chats like this or a podcast were not possible. I'd say. I'm sure there was some back then, but there is this whole aspect there. So it does sort of I feel to an extent maybe we have missed the boat on a lot of this, and we just need to trust. We just need to sort of reevaluate our definition of trust as opposed to trying to fix the solution from the root, and that is relying on what is ultimately probably going to be some big tech company, those guys or something like that.
He pointed subtly to Google for those who can't see.
Yeah, I realize this. This is an audio medium, and they can't see the video. But relying on companies like that can actually afford to do the work and establish a trust there. But obviously, if things go pear-shaped in that direction, it becomes a lot harder for us to maintain.
I think the big challenges now, I can't tell from our conversation if we're in a good place or a bad place, Ryan. Do we think the world can be saved, or is it hopeless?
I'm reluctant to say anything's hopeless. In that I don't think it can be saved in the way that a lot of idealists would want it to be saved. And it's going to be an exercise in reevaluating expectations for how we come to the solution here. And I feel that is the most on the fence answer I probably could have given to that question.
To be honest, you could not have balanced on that fence edge any closer than if you'd have tried. But I think it's a hard question, and I think that's why this podcast exists. It's why, as security folk, we're in this new phase. We've got to challenge how we embrace this future of technology that we need and want for lots of reasons. And where we draw that line on acceptable risk and how we keep what we care about secure. And none of that's easy. It's not necessarily achievable in a way that we would expect right now or that we know how to do. But that doesn't mean we give up. We just carry on. We keep on trying and building crazy, amazing things, just like you're doing at Fl0. So, on behalf of a community who no doubt is very grateful for the ability to not spend years and years writing YAML to do their infrastructure, it looks like really cool stuff. And we will check back in and see how that adventure takes you and your 10 other people. And I'm sure the Rust community will welcome all of the new people who go and have a look around and try it out now. If you were going to give folks a getting started tip for Rust, if we were going to go do it today, what would you suggest to folks just wanting to get started and understand why Rust is different?
So the biggest thing that that really sort of helped me get started in Rust is the community. I find the community exceedingly open and welcoming, and it's obviously grown over the years now. And I think it was, crikey, it was about 10 years ago. It was about 2013, 2014 that I started looking at it. But in terms of getting started, there's as much as I despise the platform, Reddit and things like that, there are very good communities there. There's a Rustling mailing list to get more involved in the language itself. And then there's a whole host of really good content in terms of YouTube. If you want 5-minute sort of videos, or you want 6-hour videos and everything in between. It seems there's a huge amount of content there, and I think that's a format I've really been, it's probably the last 2 years I've been getting into is, watching other people sort of live code and stream their coding is, I never thought would be something I'm into, but it's very enjoyable there. And then of course, you could go back to the more traditional, books. People still read books these days, and there's a Rust programming language book published for free online, as well as you can get it in hard copy from the Rust language itself. And then there's a whole host of other books. We have a hard copy of the O'Reilly Rust book, Programming Rust by Jim Blandy, and I can't remember who else. I do apologize, but a copy of that that's passed around the office, and whenever we have a new starter or someone with some Rust issue, they get the dog-eared sort of ragged copy that sort of floats around the office.
I love some things never ever change in engineering, do they? They never do. That sounds like a really great place to start. So many wonderful community things, and as a security nerd who hasn't had any chance to see how Rust does handle those vulnerabilities we don't talk about as much, like use after free and buffer overflows. I can't wait to get stuck in. So thank you so much, Ryan, for joining us today. It's been a lot of fun.
Thank you very much.
How can people catch up with you afterwards? What's the best way to connect with you?
I'm a bit of a social media hermit, but I was yes, surprising. But I think GitHub or LinkedIn actually. So LinkedIn.
There we go.
As much as I
It's
I
right,
hold strong opinions on some of these topics. and,
we don't judge.
It's the way things are done. But otherwise, my email is Ryan at Fl0.com, Fl0.com, and feel free to reach out. More than happy to chat about anything like this.
Awesome. Thank you so much for your time today, Ryan.
Thank you very much, Laura. It's been great.
And to all of us listening in, remember to like, share, subscribe, all of those things that I'm supposed to tell you and always forget to do. And remember, if you are looking to bring some secure development to your team, 1 hour AppSec is kicking off in August 2023, giving you just 1 hour's worth of work per sprint to do to bring security through your entire software development lifecycle. And best of all, it's free. So join up, 1hourappsec.com. Okay, and we will see you next episode.